Today's show is sponsored by Spot from NetApp, the cloud automation platform that makes it easy to deliver continuously optimized infrastructure at the lowest possible cost. Spot helps customers get the most out of their cloud investments by automating cloud infrastructure to ensure performance, reduce complexity, and optimize cost. Their machine learning and automation scale to exactly meet application needs using the most efficient mix of instances and pricing models, eliminating the risks of over-provisioning and cloud waste. Best of all, their software works with leading cloud platforms, services, and tools so that you can simplify and automate your cloud infrastructure wherever your workloads and applications run and however you run them. Discover how leading companies, from cloud-native startups to global enterprises, are automating, simplifying, and optimizing their cloud infrastructure with Spot by NetApp. Check them out at spot.io/cloudcast, where you can find more information, quest a demo, or even start a free trial. That's spot.io/cloudcast.
Cloudcast Media presents from the massive studios in Raleigh, North Carolina. This is the Cloudcast with Aaron Delp and Brian Gracely, bringing you the best of cloud computing from around the world.
Good morning, good evening, wherever you are, and welcome back to the Cloudcast. We're coming to you live from the massive Cloudcast studios here in Raleigh, North Carolina. Just Aaron this week, and I'm going to jump right into the news. First of all, we have Stack Overflow and their annual developer survey to talk about. We're going to talk about Datadog, a great partner of the show, and talk a little bit about their latest stock earnings. And finally, Square has a acquisition as well that we're going to talk about. So moving on to the first one. Stack Overflow, and we've talked about this many times in the past, they did their annual developer survey. They launched it back in May, and over 80,000 respondents, 80,000 developers, really fantastic sampling. Some great trends that we're seeing, some that are probably continuing, things that we've already seen. But first one I'm going to talk about is online learning. Over 60% of the respondents, they learned how to code purely online, especially younger respondents, those 18 and younger, online courses, forums, other online resources. Older respondents, on the other hand, tended to learn from more traditional online courses and more structured learning as well. Another one is AWS is still, of course, lead in public cloud, but Google Cloud and Azure, substantial gains in the last year. So what we're really starting to see is number 2 and number 3 really making some strides as their services and their rounding out of their portfolios improves over time. And another one I'd like to point out is a slight shift in the working scenarios. Of course, with COVID hitting and everything else that happened, slight drop in the number of developers that were employed full-time and a shift into more like independent contractors or freelancers or self-employment. So this indicates really maybe a little bit of job insecurity, but certainly a shift to more flexible work arrangements as well. Really fascinating. It's broken down. I'll let everyone go to the link and see more in depth about it. But, kudos to those, especially. I think there was one question out there. How long have you been coding? And I think it was like 0.2% have been coding for over 60 years. So, congratulations to them. And also, fill it out the survey on top of it. So that's fantastic. Let's move on to story number 2, Datadog. Datadog stock, they announced last week, and the stock jumped 15% on beating earnings. Like I mentioned before, a fantastic partner of the Cloudcast over the years, and part of a larger trend as well, and certainly something we're seeing on the show. The large software, and specifically software as a service folks that are out there, Asana, Cloudflare, Atlassian, Confluent, all of them saw significant jumps here recently. So this is a really interesting trend that we're really happy to see continue going forward. And for our third story, we have Square. Square picked up a company called Afterpay Limited. If you're not familiar with Afterpay, what they were was this what we call a buy now, pay later platform. And all stock deal valued at approximately $29 billion. So very significant acquisition for them. And Square, of course, continues to round out their portfolio and pick up players that are out there so that they can really expand their reach and expand their offerings as well. So with that, I'm going to wrap up Cloud News of the Week. Coming up right after the break, we're going to have Cloudcast alumni Simon Crosby to talk about business models and analytics at the edge.
Today's show is brought to you by CBT Nuggets. You know how much we value ongoing education on the Cloudcast, and CBT Nuggets is exactly what Aaron and I wish we had when we were trying to get our certification early in our careers. CBT Nuggets is all about bringing a personalized touch to learning about cloud computing, virtualization, networking, DevOps, and much, much more. Whether it's their hands-on labs with personalized coaching or the online chat functions that come up with every instructor-led course, CBT Nuggets' team of experts is always there to help you get the most from your training and your path to certification. You can check it all out at cbtnuggets.com/cloudcast and sign up for a free trial. You get access to the full catalog of great training, including virtual labs, quizzes, and other premium features completely free for the first 7 days. That's cbtnuggets.com/cloudcast. And we're back. And folks, one of the topics that we've touched on lightly, but haven't really dug into too much is kind of this intersection of all of this data that now gets generated, especially, call it the edge, but in places where we do business, where we do transactions, where vehicles are moving and all sorts of information's flowing around. And we've talked about it, somewhat this year in a couple of different instances. We've talked about event streaming with James Urquhart, and we've talked about some different sorts of databases that can manage things and so forth. But we've never kind of really put it into context. And I think maybe I've struggled personally of figuring out, like, how do we put the context of all this data together with kind of the business impact that it has. And so, as I was thinking about it, I thought, well, who better to help us really understand this than not only longtime friend of the show, but someone we always go to when we're looking at complicated challenges. So very excited to have Simon Crosby, who is CTO, co-founder of Swim.ai. Simon, welcome back to the show. It's been way too long.
Thanks, Brian. It's always a privilege.
You, by quick way of background, for folks who may not know your background, you were former co-founder and creator of XenSource, which created the Xen hypervisor. You were part of, I don't know, I'll sort of say the foundation of what AWS became. You went and
that's right.
You went and built, kind of a very, very cool way of securing endpoints with Bromium. Eventually got sold to Microsoft, and now
that got sold to HP.
Oh, HP, right? But it was kind of protecting Windows machines and so forth.
That's right.
And now you're focused on Swim, which is a whole different place. Give folks, it's been, like I said, it's been a couple of years. Give folks a sense of kind of the problem space that you're now putting your big brain on and focused on these days.
Well, I think today all products are instrumented, and every organization has instrumented its infrastructure and its supply chains and everything else. So the organizations that I see today are overwhelmed with streaming data. And they know there's something really useful in there. They just don't know how to get the insights fast. And their challenge is not so much looking at reports and deciding what to do tomorrow. It's deciding, well, it's actually getting humans out of the loop and letting machines increasingly automate infrastructure control. So, for example, a supply chain or a factory producing PCBs is highly instrumented, and we need to predict when a chip shooter, a pick and place machine, is about to make a mistake. Otherwise, we lose the production run, right? So the need to process data and predict what's about to happen or what is happening, given all the streams of data coming into the organization, is really hard. And that's a new class of enterprise data because, we've dealt with big data and we've dealt with SQL data and all the other millions of kinds of stuff you'd stick in a database. But this stuff which is streaming data. And James, you mentioned James with Flow, Confluent, and event streaming. This is a new class of enterprise data, which is fundamental to get your hands on and to understand fast for automation.
Right. Yeah, and I feel like, as I'm trying to learn more about it or kind of wrap my head around it, it feels like we have this intersection between stateful data, the stuff that's in databases and data lakes, right? So at any point I can go run a report that'll kind of give me a sense of historically what the business looks like or volume of business. And then I've got this sort of fast moving stuff, right? Things that are changing all the time. It's just the dynamics of the day and I suspect it's really hard to connect the dots between those two, because in one sense I can get business context in a big picture, and then in another sense I've got this, fast moving dynamic thing. Like, how do people start connect? Are we supposed to be connecting those dots together? Is there a way to do that? Yeah.
We have to. And so what we have to do is analyze, learn, and predict on the fly. Okay. By the way, here's a really interesting analogy. If I said to you, Brian, do you like blueberry muffins? You know the answer, right? You didn't have to phone your mom.
Right.
So how do you know the answer? You know the answer because you've learned over all these years, just given all the muffins you've eaten, right?
Right.
And so the notion here is that effectively, well, you can think of them as digital twins of things, can learn and predict continuously from their own data. And so if we create these things, essentially stateful, in-memory, resident processes, one for everything in the world, they can learn from their own data. They can understand when they're in a context of other things. And from that, we can deduce really powerful predictive and analytical elements.
Yeah. No, and it's funny you mentioned that you use that analogy. I think about it, I think we all are starting to sort of live this, right? Like, we all should be able to wake up in the morning, sort of look in the mirror, how does your clothes fit? Or you jump on a scale like, oh, okay, I gained a pound, I lost a pound or whatever. But we don't ever really think about it because it's a day-to-day thing. We've sort of put the human in the middle of our health. If the system itself would go like, hey, you're out of skew by some percentage, do this or don't do that.
Right.
Which is, I think, to a certain extent, kind of the same concept that you're implying. We have those decisions that happen every day, hundreds of times a day. We involve too many people in trying to interpret it.
Yeah, the key challenge here is the bit that I mentioned, which is you didn't have to phone your mom.
Yeah.
And phoning your mom is the equivalent of looking up state in a database. And so the problem with looking up state in a database is that many of the database schema models don't apply in the context of real world things. And we'll talk about that in a sec. But also, if you have to go over a network or you have to hit a hard disk, you're literally going 1,000,000 times slower than the CPU.
Right.
And so, it's just too slow.
Yeah, no, and it makes, well, and we've known you for more than a decade now. When we got started, our focus was in data centers, or it was in the cloud where you had everything consolidated, high bandwidth between them. Now that data's all over the place, right? Like I know we were talking beforehand, you sort of said your definition of edge is wherever you interact with data. You don't have that luxury of, super high bandwidth, or, even like you said, just having to access a disk instead of something in cache or something like that.
I think there are possibly two definitions of edge. One I gave you, which is process the data wherever you can, as close as you can to where it comes from. But the other one is this, which is that if you're going to automate, typically you want to be on the microsecond scale, right? So a few milliseconds is okay, but certainly it is not okay to cross the country to a database or anything else will take milliseconds, tens of milliseconds to reply, because the app has to run in sync with what you're trying to do at the edge.
Right. Now, what are some of the, we do this thing sometimes where, we take industry knowledge, experience, and we in one place and we apply it to another. So sometimes we think of something like the edge as well. It's just a smaller number of computers. I know you've sort of lived through this. You've got experience and opinions around, like, what are some of the misconceptions that people take about, how do I process, store, analyze data at the edge that's really different than what we've dealt with over the last decade or so?
Well, I think it's really important that we not use edge as yet another term for my data center, right?
Yeah.
It's because it's a different thing. So everybody has some legacy stuff still running in their on-prem facilities. Fine, that's okay. I think edge compute, at least as far as our largest customers are concerned, is mostly deal with processing large amounts of ingress data. So you have huge amounts of data arriving from things in your world, and you have to get responses which are less frequent out to the edge. So typically these are the multi-axis edge compute of carriers, or within a smart city or something like that.
Right.
Relatively close.
Yeah, no, that makes sense. And again, I think you highlight you've got to sort of rethink or put aside your old thinking. You can't just think of it as a small data center or anything else you've done.
No, in fact, if you even think of storing the data, you're failing.
Gotcha.
So, by the way, that's somewhat controversial, because when I talk to engineers, they often get told by senior management, store all the data forever. It's just not going to work. There is so much data arriving at many of these orgs that they literally cannot save at the rates at which the data arrives.
Yeah.
So it's not only that you couldn't afford to pay your cloud provider or whatever. It's simply that you cannot get the bandwidth to your database.
Yeah. And in real life, give me an example. Like how much roughly data are we talking about? Right? It doesn't. You can give me.
Well,
what are we talking? Are we talking about like a few gigabytes or a terabyte, or what are we talking about?
Yeah. So Swim works with a large mobile provider in the US, and we analyze, learn, predict on the fly from more than 4 petabytes per day for them for a national app. So the app but here's the funny thing, Brian. We all lived through big data, right? And big data was a few people who escaped from Google and did Hadoop, right? And so, these guys had 400 nodes of big data, right? And they were getting insights on about a 10-hour time scale. Okay, now I'm just going to tell you what Moore's law has done, and you should just say, oh yeah, that's obvious. Swim requires only 40 nodes instead of 400, so it's 90% less. Okay, and we move the insight from 10 hours to 10 milliseconds. Okay, and by the way, that's just Moore's law. So everything is in memory. And these digital twins listen to their own real world streaming data and analyze, learn, predict on the fly. Okay. Yeah. So, there are so many databases out there that it's kind of boring, right?
Right.
And the database really has reached its limits. I'd be happy if Snowflake was the last one, but who knows?
Right. Yeah. Yeah. No, Snowflake is, and they're still they're kind of finding their place, but it's mostly in expansiveness, not so much in real timeness.
Right.
I'm curious. You get a chance to work on some very interesting new things, right? We sort of established early on this is a new frontier. What are some of the concepts or types of things that people are now able to do? Because they can put context around this real time data, they can process it, they can learn from it. Like, what are some of those types of applications that you go, oh, okay, that's now possible?
I'll give you a couple of examples. So for the mobile use case I mentioned, where we have effectively digital twins for more than 150 million devices.
Wow.
Each of which is aware of its own position and its own connection quality to base stations and its proximity to others, right? So proximity to other devices and stores and a whole bunch of other stuff, right? And then these things learn and predict from their own past so we can decide how best to optimize their connection. So how do I decide how optimally to connect you to the next base station in your life? Well, I know what you did yesterday at this time, okay? And so I can predict ahead where you're likely to go, where you're likely to be, what sort of connection you're likely to see. And also, given weather and the radio signal attenuation from base stations, we can predict what the signal is likely to be, where you're likely to go next. Okay. And that gives us an ability to dynamically tune the radio network for the provider. That's a big deal. Okay, let me give you another example. I gave you one example for predicting when a chip shooter is about to make mistakes assembling PCBs. Let me give you a smart city use case. In Dubai, if a truck has bad braking behavior or bad cornering behavior, then we can direct it in real time to the nearest inspector on the street.
Wow. Yeah, no, it's well, and I'm glad you gave those kind of two different environments, because I think sometimes people, they associate something with kind of only being tied to a vertical. Oh, this is a telco technology. This is a manufacturing technology. That, like you said, there are so many things now that are instrumented, and as we see interesting business models come along where people are able to analyze, what's the cost of repair, what's the cost of outage, what's the cost of responsiveness. I think we're going to get into some really interesting, new businesses that emerge now that it's like, oh, okay, there are ways to optimize these things that we never thought were possible.
Yeah. And the challenge in general, as we go on this path, is to make this approach to, you mentioned the horizontal, this approach to writing, I guess, distributed applications which consume real-time edge data, make it part of the natural way that people think, as opposed to thinking I have to write some SQL or something that pulls data out of a Mongo or whatever, right? So we need to get out of this think of database first into insight first. And how do I compute the insight from the context? What is the context? And what do I do then?
What are, like you've had a chance to work on this for a while. What are, I don't know, as you're talking to people that are newer to this space, or you're introducing the capabilities to people, like what are some of the kind of real foundational things that they need to get right? Whether it's the way they think about it, or some of the technology choices they make. Like what are the stepping stone things that you can't screw up?
The simplest thing is don't store all the data. Or at least, don't store the data. The quicker we can go from raw data to insights, fine, store the insights, the better, right? But this idea of storing all the raw data is just stupid. So occasionally I'm delighted to fire a customer. And one of them was this. So here's a customer who had, they aren't a customer anymore. They had 40 large compressors, okay? And compressors are generating 70 data points per degree of rotation of every shaft. There are 4 shafts per compressor, and every shaft goes at 2,500, 3,000 RPM, okay?
Yeah.
So they're generating shitloads of data. And their idea was, cool, we'll just build a MongoDB, right? And where I left them, they were buying hard disks, okay?
Yeah.
Because there's just so much data coming off these things. And here's the use case. The use case was predictive analytics, right? So when is this thing going to fail? Well, the thing behaved in the following way. It was the same for 4 years, and then it failed.
Yeah.
Or maybe it squealed, in 3 weeks before it failed. So there's just a vast amount of data which is kind of useless. And getting quickly from data to useful insights in as simple a way, as close to the data as possible, and then throwing away the raw data is very valuable.
Yeah, it's almost like we have to. It's like you said, we've lived through a decade of quote unquote big data and data lakes and store everything, and storage is cheap, and you almost have to deprogram people from that, because you're not solving a historical problem. You're typically solving more now problems or short term problems. Yeah.
And let's be clear, storage for 4 petabytes a day is not cheap.
Right. Yeah, I'm sure there are plenty of storage companies that would love for you to make those mistakes, but it's not good for your business.
And, I think the majority of these applications are in the cloud, because when there's lots and lots of data, people tend to put them in the cloud. The storage, the cloud vendors all make money by marking up storage, right? And they charge you a lot to put it in, but more to take it out.
Right. So yeah, they encourage you to keep, because it seems like it's cheap to get it in, right?
And once you're in, you're there forever. Yeah.
Right. Very good, Simon. We could probably talk about this stuff for a very long time. Like I said, I wanted to pick your brain because there were some dots that just weren't connecting for me, and this has been super, super helpful. What are some of the big things that Swim's working on before we go? If folks want to engage you on real things as opposed to just discussions like we're doing.
Well, the big thing for Swim is, as you mentioned, we're horizontal, right? So Swim is an open source platform which really just lets you write very simple object-oriented apps in Java. And we build this active framework which works in a distributed way. The big evolution for us is rewriting the core in Rust, which is really fabulous language. It's type safe, it's very secure, and very performant. And then the adoption of HTTP2 and incorporation of that into the actor model. That's the big evolution ahead.
Yeah, nice. Keep it moving faster and keep it modern. Excellent.
Yep.
Well, listen, Simon, as always, thank you for some time, for some insight. We really, really appreciate it. Folks, we keep digging into, new ways to manage new applications and data, and hopefully this helped you a little bit. With that, I'm going to wrap it up. I want to thank everybody for listening. Thanks, everybody, for telling a friend and helping us grow the show and the community. And with that, we will wrap up, and we'll talk to you next week.
Thank you for listening to the Cloudcast. Please visit thecloudcast.net to find more shows, show notes, videos, and everything social media.